Hello and welcome to this. It's not a tutorial, I got tangled up in the plant. It's a devlog, a devlog, development log as we make 3D Snake in Unity. But I don't want to stop there. I want to have a community of two types of snake. Some hunter snakes, some chasey snakes, and like prey snakes, or snakes that are chased by other snakes. And then I want to have that, what's it called, like foxes and rabbits simulation dynamic to happen, whereby the population of these two communities, the hunters and the hunted, kind of change together. That's the idea. That's a long-term idea, and it might take several videos before we get there. But first we want to create a 3D snake. Moving in the classic 2D snake way, but in a 3D environment, which I've never done before. So I haven't prepared this at all, except for briefly thinking about how I might do it. And I'm going to do that with object pooling. So I've got, as in my previous videos recently, I've just got a Minecrafty voxel landscape, and I've already got a pooling system kind of working. And which I'll start again from scratch, and I've also got a pixel sun, just in case, and it's actually orbiting. It's moving around us right now. That's just in case you catch sight of that and didn't know what on earth was going on. Right. So in this environment, this like small arena, we'd want a 3D snake. I'm thinking made of blocks. I think it would look good if it's kind of like a voxel block, with maybe a tail of 10. Or so. Of course, we could add tail segments and delete tail segments depending on what behavior we want. But first, let's try and make a snake and have it moving around. Okay. So I've actually got a drawing board ready. Here we go to make. Oh, it's maximized itself. There we go. So we want to have. Let's choose pink again. We want to have a cube, and we're going to attach a script to this cube that does what? That every so often decides to move in a certain direction. We could go right, we could go left, we could go up, we could kind of go forwards, and we can go down. But we can't go back on ourselves. That would be the rule for the movement of the snake. So in our script, just write, oh, look at that handwriting. It's actually better than my normal handwriting. Right, so in our script, don't need that line. In our script, what do we want to do? We want to kind of decide which direction, WD, and that's going to be out of, switch back to pink here, that's going to be out of 5. And we maybe only want to change direction every, 10 movement. Now, we don't want our snake to be constantly moving. By the way, I'm thinking about this as I'm talking. So we don't want it constantly moving, else it's going to go very fast. We want to have some kind of like timer, so like every second it moves, or every half second, that we can change easily. So let's say every 10 moves or something, every 10 moves, we then want to decide on what direction to go. So after 10 moves, it's then going to decide randomly what direction to move in. And we want to organize this via an object pool. So at the start, it'd be brilliant to kind of generate a number of cubes. We might have to use a for loop to kind of like place those in a line. And then we're going to have one cube being the head. And basically 1, 2, 3, 4, 5. If we've got 5 cubes, we want to, on the next turn, let's say it decided to move here straight ahead. So it's going to move there, and what we want to do is kind of cancel out this cube, and we want to move it over here. And by cancel out, I mean we just want to change its world position here. Okay, so we wouldn't really need to object pool, but if you looked at my first video, which was in JavaScript 2D object pooling, we kind of got a snake behavior happening automatically. Right, we've got some kind of plan. Let me have a look at the time. Okay, it's 4:10, so I'll make this about 20 minutes. So by 30:30, or if the doorbell rings, I'm expecting someone, then I'll stop then, whichever happens soonest. Right, go back into Unity. So let's make a new folder in our assets, and we'll call this snake. So that all our snake bits and bobs will go in here, so we're nice and tidy. Right, first of all, we need a block. There we go. And we'll call this snake. Now, what I really like is when everything is kind of like contained. All I really want is this one cube and a script, and everything will be kind of generated by it. So I don't have to do anything else in the editor. I want to do everything through the code. I think that's more elegant. So we'll create a C# script, and we'll call this our snake brain. There we go. And I'm going to attach this straight away to our snake object, our snake cube. There we go. What can we turn off? We'll keep the collider on for now. We don't need any blend probes. Yeah, receive and cast shadows. Okay, that won't slow down the program too much. And where's it located? We'll put it, I don't know, 9, 9, 3. Let's just go and see if we can make sure that we've got our snake cube in the world. Oh, of course, it might be. It might have just spawned underneath our terrain. Let's just see where he is. So we'll pause that. Snake cube. Oh dear. There we go. Let's just manually lift you out. And remember, so we put it 10 meters or 10 units high. Oh dear. Oh, it's almost out. So if I place him there, what's that? 16. We'll call it 17. 17 units high. Can we go and find our snake? And sometimes just making it, just taking very, very simple steps like this can kind of help you think through how you want to do something. Okay, now I've got to go and find him. Oh, there he is. So he's down here. He's in this like secret part of the world. As I was saying, sometimes just having something visually there to interact with can help you think through things. So the first step, we want to, let's not get crazy. Let's say, oh, let's get crazy. Let's say we want to generate a pool of 10 cubes. And I wonder if it can copy itself. Can I do that with instantiate? I think so. So let's go into our snake brain. There we go. We don't need our sun orbit. Snake brain. The first thing we want to do at start is kind of generate tail. Okay. Generate my tail. That's going to be void. It's not going to have a return type. Generate tail. It's not going to take any parameters, any arguments. There we go. And so what do we want to do here? We want to clone the head and position n tail segments behind us. That's what we want to do. Okay. So I know I'm going to have a for loop because, you know, we want to do this kind of incrementally. So for int equals I equals 0, while I is less than, we'll call it segments, I plus plus. And so in this for loop, we want to game object instantiate, game object dot instantiate object original. I've never done this. Let's see if I can just say this object. Can I do that? I might have to put this dot game object. I'll just see if that works. Of course, we need segments. So at the top, we need to create ourselves. That's going to be an integer, not a float. We're not going to have 9.73 segments. Well, that'll be interesting to play around with. It could be done. So we'll say int segments equals default 10. We won't make that public yet. Okay, so we've got 10 segments. That's going to go around 10 times. And so they're just going to be created on top of one another, I presume. And we want them to go behind us, which means negative forward axis relative to this game object. So let's make temporary variables to hold each of those segments. So we'll say game object s equals that. Now we can grab hold of each new segment created, and we can say s dot transform translate. That needs to be a capital T. Translate. So the vector3 translate function, that takes a vector, i.e. which direction in 3D space you want to go, and we want to go negative this forward. So every game object with transform will have a forward. And that doesn't mean just along the z-axis in the world space. It means whichever way that object has turned, its forward will correspondingly change. So later on we're going to move our snake around. We'll always be able to use that forward axis, that private forward axis, to understand where it's going. Right. And we want to put it back. We want to put it back, so we're going to say minus I. Okay. I think that will work. Hopefully it will accept I as a float. Usually when you're dealing with vectors, they like to interact with floats. Let's save that. And it's 4:20. I think I've heard my friend arrive. So I'm going to maybe have to cut this video a little short. But hopefully we'll get 10 segments. Will that work? Yep, generate tail in the start function. See if it... Oh, there can't be a bug. What did I do? Game object s equals... Do I have to write new here? Oh! It was that problem I thought maybe we have to write instantiate this dot game object to clone this actual game object. Let's see if this bug goes away. Yes, I think we're, yep, it's gone green. So we can go. Sip of tea. Okay, it's black. That took a long time to load. I think there's a problem. What on earth could the problem be? I've only got 10 segments. Anyway, I've crashed. I've crashed Unity. What on earth did I do? Clone this. Oh! Oh my god, do you see what I've done? Right, I need to force quit. That was the dumbest thing ever. Okay, what if you haven't realised yet? What I've done is force quit Unity. This is staying in the video. This is real programming here. Right. What I've done is I've cloned this game object, which once I open Unity again, which is our snake head, and of course, the snake head is going to have this script on. And what's it going to do when it's first created in the world? It's going to generate a head. So every head that was created will then create 10 more heads, and so on and so forth. Which is like a bit of a recursive kind of behavior. Which is beautiful. So I'm going to stick to my guns. I want to clone this snake head. Oh, I didn't save. Oh, there's snake. But I didn't save the scene. So all we have to do is create a new empty. He was at 9, 17, 9, I think. And we'll call him Snake 1. Snake 2. Snake version 2. There he is. Right. Is he empty? I created an empty. Whoops, I need to create a 3D object cube. There we go. Call you Snake 2. 9917, thank you. Oh yeah, take off the blend probes. Oh my god. Yep, we can receive shadows and things like that. Okay, so now we've got our Snake 2. We'll attach the snake brain to her, and before we run it, let's just save the scene. I should have created a new scene. Now I'll be alright. I have made a tutorial based on this one. Anyway, so this time we we want to only generate we don't want to generate straight away. So we want to do, can we do something like this? If ready, then generate. Public bool ready equals false. So now when we clone our object, will that clone whether it's ready or not, or will it rely on the default? This is a difficult one to play around with because if it goes wrong, it crashes and it takes a while. Okay, what's an easy way to do this? I mean, there is an easier way. I just create a primitive down here. But I want to have like this recursive kind of functionality on it. So, okay, 6 minutes. 6 minutes to solve this problem. How are we going to do it? Well, in terms of the tail segments, everything's okay. They're just being generated without this function running. But we want this first guy to generate. What we could do, we could say ready equals false straight away. And then in our scene, we could make that is public. So we can say this one is ready to go, but then So he will generate tail. That will be set to false. And then, and the default is set to false anyway. So then when we clone him or her, when we clone her, we won't get the recursive regeneration of snakes. That's the plan. Let's see if that works. Got 5 minutes left. Okay, it's going black. Oh, okay, we generated a lot quicker. So at least we didn't get the recursive bug. And yes, some success. We've got our 10 segments. Okay, I think it would look cool if they were kind of spaced out a little bit. So we can see each segment. So, still got 5 minutes. This is like the longest minute of my life. How's that happening? So we'll just adjust the code slightly. Now I like this. It means every one of those segments had this script attached to it, which is probably not very optimal, but it means they've got so much potential. We could possibly, this is cool. For later on, we could have it so that each segment then generates its own snakes. And we can get like a tree of snakes. See, sometimes from bugs and stupidity you get interesting things. Right, so what am I doing? Oh yeah, I'm going to space those out. So at the moment we've said we're going to instantiate each segment, and then which we hold in the S variable, this temporary variable, and then we slide it backwards, i.e. along the z-axis relative to the snake head times minus I. So we could say I plus 0.25. Will that? I think that will that just crush? We better put these in brackets. I'm going to say this might just crush up the segments together. We should have them spaced out. Okay. 3 minutes left. Yep. That hasn't worked at all. I've basically just moved the whole lot along. Okay, maybe I don't need the brackets. What am I doing? Yeah, I don't need the brackets. That's the whole point. So it'll be I times I. So times like 3 plus a little bit times 4 plus a little bit. But I want that to plus cannot be I cannot add. Of course I can't add a float to a vector 3. I bet this is so simple when the camera's not on. Let's see. How long have I got? I've got 2 minutes to do a very simple problem. For times I times 2. Oh, I need to, my goodness, times yeah, can I just say times 1.5 again? I think I'll get the same bug as before. No. Oh no, because I'm timesing this time, multiply. With a float, which is okay. Okay. There we go. I solved it within the time. That took way too long. Right, there we go. So I've spaced out. That looks nicer. That's what I'm kind of expecting. Maybe you could squeeze them up a little bit, but I'll leave them like that. So that's the end of the first video. We've got a snake set up. In the next video, we'll get her moving. Right. Apologies, and thanks very much. Let me know if you're enjoying, by the way, this kind of this style of video. It's not really a tutorial, and I don't really know what I'm doing until I'm going along, so it's kind of like creative coding, which I quite enjoy doing, except the I don't mind the embarrassing moments, as long as there's, I don't know, as long as there's a result. Okay, thank you very much. Enjoy the rest of your day.